Okay, so again, good afternoon. Thursday, February 21st. We're looking at Section 7 today. This is our 6th class meeting, and we're looking at Section 7. I just want to remind you of what is coming due here. We have everything from Unit 1 is due by Saturday. So if there were things that were late, still partial credit on those, turning them in by Saturday, and then the project is due Saturday, and then your exam needs to be done by then also. And let's see, so Batul, you can go ahead and ask your question. You have a question about percentile. Tell me where you saw it, because I don't know that we covered that in the course so far. Or are you working ahead? If you're working ahead, that's great. We'll answer that later. All right, so the assignments that are assigned today, due on March 1st, those are WebWork 7, so it goes with this section. And then we have another Excel paper. It is on absolute and relative change. And then you should be using formulas. It's really just subtracting and dividing. And then discussion board number 3. So that's what's coming due next week from today's lesson. All right, so if you would flip to page 71 with me. We have, let's see, absolute and relative change. And it says here, in this section, we will look at ways to describe change and make comparisons. Absolute change is the difference in two numbers. A positive number is a positive change or increase, and a negative number is a negative change or a decrease. So all we do is we take the new value and subtract the old value. So, or the new value minus the starting value, or the reference value, we call it here. So in question 1 here, it says, Juliet's weight went from 180 pounds to 162 pounds from May to December. So here's the starting amount, 180, and here's the new amount. So we would do 162 pounds minus 180 pounds, and that is negative 18 pounds. And so the interpretation of that would be that Juliet lost 18 pounds. So we wouldn't say she lost negative 18 pounds. We would just say she lost 18 pounds. So lost is another way of interpreting that sign right there, that negative or that minus sign. So number 2 says the median income in the US was $57,230 in 2015 and $59,039 in 2016. So we want to find, again, the absolute change. We're finding the absolute change. So it's just subtracting them. So this is 59, the new amount, 039, minus 57,230. And let's see how much that is. You can always help out if your calculator is handy. It looks like it's going to be $1,809, so $1,809. So we could say the median income in the U.S. increased $1,809 from 2015 to 2016. So since it's positive, we say it's an increase. If it's negative, we say it's a decrease. So let's look at John and Miguel. So the first thing we're going to do with these, before we even look at these questions, is we look at these heights: 6 feet 2 inches, 5 feet 9 inches, and we know we're not going to be able to subtract those in the form they're in. We want to change those to inches. So John is 6 feet, that's 72 inches plus 2, so 74 inches. And Miguel is 5'9", so that's 69 inches. And then let's answer these questions. So it says, compare Miguel to John by finding and interpreting the absolute change with John as the reference. So since John is the reference, we're going to do Miguel minus John. So we always subtract the reference. I see your guys' answers in the chat box. That's awesome. So it's 69 inches minus 74 inches, which is negative 5 inches. What does that mean? That means that Miguel is 5 inches shorter than John. That's how we would interpret that. Miguel is 5 inches shorter than John. We wouldn't say he's negative 5 inches shorter. We'd say he's 5 inches shorter. So shorter is a designation from that negative sign right there. So part B says, find and interpret the absolute change with Miguel as the reference. And we want to answer this question. This is comparing John to Miguel. So now Miguel is the reference. So we're going to do John minus Miguel. And this time we get positive 5 inches. That means that John is 5 inches taller than Miguel. And he wants to know if we got the same value. What do you think? Correct. The values are different. So the absolute value is the same, but the value is different. One is positive 5 inches, one is negative 5 inches. So no, the values are different. So the order of subtraction does matter. And you probably already knew that. So the next one here on page 72, if you follow me over to that page, says relative change is the ratio of the absolute change to the reference or old value. A positive number is a relative increase, a negative number is a relative decrease. So if you look at the formula, the top part is what we just did. We find the absolute change. So all we're doing is taking the absolute change divided by the old value. So in this example, it says the US population was 298 million in 2006 and 323 million in 2016. So we take the new population, 323 million, minus the old population, 298, and divide it by the old population. We get 0.084. Now, when we deal with relative changes, we want to convert these into percentages. So we move the decimal 2 places to the right, got 8.4%. So relative changes, if it asks for the decimal value, that's fine. But when we use it to interpret data and to quantify it, we use the percent. So it says here the US population increased 8.4% from 2006 to 2016. So that's how we would make our quantitative statement. So let's look at these two examples again that we just looked at with Juliet and the median income. So we already found that Juliet's weight went down 18 pounds, right? So that's the absolute change. It's just the top. Or we could have written it as the 162 minus 180. If you want to start all over again, that's fine too. So divided by the original weight. So the original weight was the 18, or the, 180. Notice how the 180 is on the right side and on the bottom. So whatever number is on the right side, that should be on the bottom also. And so negative 18 over 180 is, help me out, negative 0.1. So negative 10%, or a loss of 10%. So we would say, so our interpretation would be Juliet, so here's how we would write this. Juliet lost 10%. Don't say she lost negative 10%. Say she lost 10% of her weight from May to December. Okay? So don't say she lost negative 10%. Say she lost 10%. So the lost is representing that negative sign. If it were positive, we'd say she gained 10%. And then that median income, remember we already subtracted these 59,039 minus the 57,230, and we're going to divide that by the 57,230, the original value. So that was 1809 divided by 57,230. And then let's see what we get there. So 0.032, so we could say that it went up 3.2%. So we'd say the median income in the US went up 3.2% from 2015 to 2016. That's the statement we would make. All right, let's go back to this John and Miguel. So remember, John was 74 inches, Miguel was 69 inches. Yep, all right. So let's see here. We're comparing Miguel to John. So that was the -5, if you remember. And we're dividing that by John. So -5 divided by 74. So taking out a couple of decimal places, we get 0.0676. That'd be -6.8%. So we would say that John, or excuse me, Miguel to John. Miguel is 6.8% shorter than John. Okay, in that value, because we're comparing to John, so it should be shorter than John. We cannot say that John is 6.8% taller than Miguel because we're not comparing to Miguel in this question. So it says, should we expect the same outcome if we were to use Miguel as reference? No, I'll give you that, but why not? What are we doing different if we're using Miguel as the comparison person? Let's look at the calculation. 74 minus 69, if you use Miguel as the reference, what are we going to divide by? Yeah, this time we're dividing by 69. So see how we divided by the 74 the first time? Yep, we have different denominators, that's right. We are dividing by a different number. Different denominators, dividing. We're dividing by a different value, not a valve. Okay, so we're going to do this one. So now we're doing 5 divided by 69. And that one you guys got 7.2%. Oops, let's try that again. 0.072, so 7.2%. So now what we can say is that John is 7.2% taller than Miguel. So do you see how Miguel is 6.8% shorter than John, and John is 7.2% taller than Miguel? The reason those answers are different is because we're dividing by a different number each time. So be careful when you look at these and you answer questions about making these comparisons. How you define the reference value, that determines what that percent's going to be, and it changes. All right. Any questions so far? Very good then. Let's look here at page 76. So roll over to page 76 with me. And let's look at some working with absolute changes in percentages. So it says here, at this point you have worked with changes in things like dollars, pounds, inches. What about changes in percentage points? According to the U.S. Bureau of Labor Statistics, the highest average annual unemployment rate in in recent history was during 2009 at a rate of 9.3%. By 2015, the average annual unemployment had dropped to 5.3%. So see how both of those numbers are given in percentages instead of dollars or inches or pounds? So let's look at this. It says when working with absolute changes in percentages, think percentage points. This means we will not convert the given percentage values to decimal values during the calculation. So even those are given as percentages, we're not going to convert them into decimals to do the calculation. So the absolute change is just subtract new minus old, negative 4 percentage points. That means that the unemployment rate went down 4 percentage points. And then we can find the rate of decrease. This means there was a decrease of 4 percentage points. So let's see, the relative change, negative 4 divided by 9.3 is negative 43%. So now the difference is, see how we found the relative change? We got a decimal. We're going to convert that to a percent. So this percent is the relative decrease. It's not the change in percentage points, okay? So it says this means there was a 43% relative decrease in the unemployment rate from 2009 to 2012. This should say 2015. So a 4% difference, but a 43% decrease. So 4 percentage points difference, 43% decrease. All right, so let's look at number 1 here together. It says here, according to the CDC, in 2014, the teen pregnancy rate was at its lowest ever at 2.42%. In 2013, the teen pregnancy rate was 2.66%. Find and interpret the relative change. So find and interpret, that means we're going to calculate it, and then we're going to write a sentence describing it. We're going to take new minus old. So the new one is 2.42. The old one is 2.66. And we're going to divide that by the old. So let's see, in doing that, go ahead and see if you get the same thing I get. So go ahead and type in an answer, and then I'll put mine up there. Yep, so we got 0.24 negative over 2.66. Then we have to divide that, and we get So that means, okay, so negative 9%. So if we're going to interpret this, we would say teen pregnancy rate decreased or went down 9% from 2013 to 2014. Okay, so that's how we interpret that. The teen pregnancy rate decreased 9% from 2013 to 2014 because of the negative sign right there. All right, let's look at number 2 on the same page. So here it has a 37.9% of adult American men obese, and in South Africa, 11%. So we're going to find the absolute change, and we're going to calculate a relative change comparing the US to South Africa. So here we're comparing South Africa to the US. So we're going to do South Africa minus the US. So 11 percentage points minus 37.9 percentage points. So negative 26.9 percentage points. So we could say something like South Africa's obesity rate is 26.9 percentage points less than that of the US. That's how we would say that. South Africa's obesity rate is 26.9 percentage points less than the US. So let's look at this if we're comparing the US to South Africa, and we're going to find the relative change this time. So the US to South Africa, so 37.9 compared to South Africa, minus 11. The relative change means we need to divide by the reference value, 11. So when we divide those, notice that the top is going to be a larger number than the bottom. The numerator is larger than the denominator. And so we're going to get a number bigger than 1. So we get 2.45. But that's not the percent. We need to move the decimal 2 places to the right. And we get a relative change of 245%. And then we want to be able to interpret that. So the interpretation would be the obesity rates of adult men in the US are 245% higher than obesity rates of adult men in South Africa. So up here in part A, sorry about that. Okay, so in part A, we have just an absolute change, so it's 26.9 percentage points less. So South Africa, 26.9 percentage points less than the US. And then the relative change, comparing the US to South Africa, we have a relative change of 2.45 or 245%, which means that the obesity rates in the US are 245% higher than the obesity rate in South Africa. All right, hopefully that wasn't too bad for you. So we're going to look now at page 79. And we have just a couple more things left. Okay, so on page 79, we're looking at percent change, and we're looking at the wording so that we're able to do some calculations in some scenarios. So it says here, oops, I should just put that up there. Earlier, we learned to calculate relative change in order to make comparisons using percent change statements. In this section, the percent change in one of the values in the comparison is known, and we are asked to find the unknown value in the comparison. So it says here, when relative changes of percent increase, we add it to 100%, and when relative changes of percent decrease, we subtract it from 100%. So let's fill in this table. 10% less than something is 90% of the original. It's like 10% less than the original is 90% of the original. A 25% decrease is 75% of the original. 30% lower than, 70% of the original. 60% less than is 40% of the original. So if we have a percent increase, a relative change that's positive, like an 18% greater than, that would be 118% of the original, 150% of the original, and 200% of the original. So there are two ways to work these problems we can find on page 81, and one is with a proportion and the other one is with an equation. And what I'll do is I'll just show you both methods. And so it says here, Megan is currently enrolled in 16 credit hours, but wants to decrease her credits by 25% over the summer term. How many credits will she take in the summer? And so I'll show you two correct ways to set this up. We can put the reference values on the bottom. So her 16 credits that she's currently taking, 100%. And then we want to know how many is she going to take in the summer term credits, and what percent of the original is that? Well, if it's a decrease of 25%, that means it's 75% of. So that's how we would set this one up. If we put a 25 where the 75 is, then we would have found the number of credits, the number of credits fewer that she's going to take. We wouldn't have found the actual number that she's going to take. So that's one way to set this up. Another way we can set this up is we can say that the new amount is 1 plus or minus the percent as a decimal times the reference or the old amount. So if we were going to set this one up with an equation, we'd say the new number of credits is 1 minus 0.25 times the reference amount, which was 16. So again, it's going to be 0.75 times 16. And that's what this ends up being. 75 times 16 is 1200, divided by 100 is 12. 0.75 times 16 is 12, so 12 credits. And I see that several of you have that in the chat box already, so awesome job. Looks like Persinger, Westbrook, her areas. Yeah, okay, good. Or her. How do you say your last name, Megan? Is it her? Just tell me if it's yes or no. Is it her? Hair? Okay, good. Okay. So, all right, and I see you're coming in there too. So either way, of either of these two, with a proportion or with an equation, either one is fine. And so let's see, number 5, we're just going to do a couple more together. Then we'll have you guys work in groups, okay? So it says if the take-home pay is $14.43 and 22% was withheld in taxes, what is the gross pay? So the first thing we have to know is the take-home pay and the gross pay. Which is the reference value? Like, which is the original value, the take-home or the gross pay? The gross pay. Thanks, Melissa. So the gross pay is the reference value. So that's 100% of what you make. And we're trying to find out what the gross pay is. Now we know the take-home pay is $14.43. And it says 22% was withheld. So what percent is the $14.43? That's not the amount that's withheld. It is 78% is withheld. Very good. I see that you have that in there, Brian and Stephanie. Good. And now Melissa and Nicole. Awesome. So we're going to do 1443 times 100 and then divide by 78. And again, if you want to do that with an equation, we'd say the new amount, 1443, is 1 minus 0.22 times the reference amount or the gross pay. So 1443 equals 0.78 times the reference amount. And in this case, if we're doing with the equation, we have to divide by 0.78, divide by 0.78. And the whole thing here is, you know that you should be getting a number that's larger than 1443, and it is 1850. I see that some of you have that in there. You should know that the gross pay is larger than the take-home pay. And so it's 1850 compared to the 1443. Okay, so if you got a number lower than 1443, then you know you did something wrong. All right, so last one I'm going to do with you, the next ones you're going to do on your own and in a group. All right, so it says number 6, Julian recently joined a carpool. Although she drives 22 miles from work, on her day to drive the carpool, she drives 30% further to pick up her colleagues. How far does she drive to work on her day to drive the carpool? So actually, I'm going to have you do this one on your own. Don't put your answer in the chat box yet. Just give me a hand raise when you have an answer, okay? So give me a hand raise when you have an answer, but don't put your answer in the chat box yet. And I'll give you a minute or two to do that. All right, so it looks like most of you are done with this problem, so we'll go ahead and take a look at it. It looks like her original amount is the 22, and it says she drives 30% further. So what is that going to be up in this number right here? We got some conflicting answers. So further, what does that mean? Less than or more than? It means more than, so it's going to be 130. So the mileage she drives when she drives the carpool is going to be more than 22. So that percentage has to be higher than 100. So in this case, we had to add the 30%. So we're going to do 22 times 130 and then divide by 100, and we'll find out how far she has to drive. Yeah, it looks like 28.6 miles. And then if we set that up with an equation, we'd say the new amount is 1 plus 0.3 times 22. So 1.3 times 22. And it is 28.6. So you should have found a number that is bigger than 22. If you used 70 here, you would have gotten a number that's less than 22. And so when she drove the carpool, she'd be driving less than if she drove straight to work, and that doesn't make sense. So let's look at this last piece here. On page 83, it gives a little description. It says, does a 20% increase followed by a 20% decrease net to zero? Does a 15% increase followed by another 15% increase equal a 30% increase? It can be difficult to think through these scenarios in the abstract. It may be helpful to create sample values to think through these examples. And it says, consider the following. On page 84, number 4, it says here, if an actor loses 10% of his body weight for a role, will he return to his original weight by getting 10% of his new weight back? And I'm going to separate you into groups to do this question. Remember, there's going to be a tab that pops up. You might have to click on the tab, unblock your pop-ups, whatever. But we'll do this. I'm going to have you work in your groups and answer this question, and then we'll bring it back with a few minutes left in class so that we can wrap it up. All right, room B. So as you guys are looking at this, just talk to each other about it and come up, be agreeable with your answer and have some reason why you agree with that answer, okay? Okay, welcome back. So I do want to make this announcement though, so I don't forget. So if we're in class and it appears that I should be talking and you can't hear me, in the chat box, don't say I can't hear you. Say, hey Falutz, check your mic cord because sometimes it doesn't say insecurely. I remembered that just now. So shoot me that reminder if ever you can't hear me and it looks like you should be able to hear me, okay? All right, so let's look at this question. It says here, we want to know if he goes back to his original weight. So 200 pounds is what he starts with, and he's going to lose 10%. So that means he's going to be 90% of his weight. So 200 times 0.90 is 180 pounds. So he lost 20 pounds, right? So now we want to look at this and say, if he gains 10% of his new weight back, what will he weigh? Well, if he's 180 pounds, he gains 10% back, then what are we going to multiply by here? He gains 10%, so it'd be 110%. So 1.10. That would make it 198. Oh, not quite 200. Yeah, and the reason is because in the first part, we're doing 200 times the 10%, which gives us 20 pounds. And in the second part, we're doing 180 times the 10%, which is only 18 pounds, which gets us up to 198. It doesn't quite get us back. So a 10% decrease followed by a 10% increase does not get you back to your original. So think about that. If your boss said, hey, we're going to give you a 10% decrease in pay this year because we're struggling, but next year we'll give you a 10% increase. Well, guess what? Next year when you get that 10% increase, it's not going to be what you were making before the 10% decrease. All right, so just some things to think about. And then remember that web work number 7 and the Excel absolute and relative change is due next week, and then the discussion board number 3. Okay, read the discussion board carefully, okay, when you do it.